Okay, here we go. All right. Now, I'm going to tell you this. I think your notes on this chapter or this section are just a little too much. There's too much wordy stuff going on. So I will be canceling a lot of stuff. So please keep your eyes up here so you know what to cross out. Because I'm not talking about probably a third of this. All right. Here's what you're doing. This is your last day. You'll have to learn a new graph in Algebra 2. So this is it for graph until you get to the final, and then you have to kind of know them. You have done this. You have done linear functions. You have done quadratic functions. You have done absolute value functions. You have done exponential growth, decay functions, logarithm functions. You've done a lot in here. This is the last one. It's called the what function? Reciprocal function. The reciprocal function is right here. I'll say y. Y equals at 1 over x. And this is known as the parent. When I say let's graph reciprocal functions, I'm going to start you with the parent. So let's start right here. Let's graph the parent reciprocal function. And that's it right there, by the way. Okay? So I'm going to rewrite it right here. Instead of saying f of x, I'm going to say y equals 1 over what? X. This is known as your parent function. Every time you graph a reciprocal function, it is this function, except you might go right, left, out, down, stretch, compress, and reflect. Okay? So first we got to figure this out. So to figure it out, we're going to start with tables, like we always do. And then after this, guys, we won't be making tables, so you have to memorize what this function does. All right, good number to start with always is 0. Okay, then what? Then? Oh, yeah. Okay, I'm going to do the positives, and I want to show you what happens with positives. Ready? Put it in. 1 divided by 0.
Okay.
0? Is it?
You can't divide by 0.
It's undefined, right? You can't divide by 0. So no what?
Solution.
No solution, which means there's no point. When you let x be 0, oh, nothing happens. You don't even get an answer, no point. Let's let x be 1. Let's let x be 2.
Yeah.
Half, 3, third. Okay, now, you guys, there's a pattern here. Now watch this. 1, 1 is here. 2, 1/2. 3, 1/3. Okay, you can kind of see it forming. It's kind of going that way, but what's it going to do? Is it going to start to do this, come back up? Is it going to cross the x-axis?
It's going to ride it.
He's going to ride the x-axis? You sure?
Yeah.
What if I plugged in a 10? What would be the answer? 1/10. Where am I at now? Right on top of the x-axis, just 1/10 up. So guys, right here, you're basically right on the x-axis. So you're right, it's riding the x-axis this way. So when you ride it that way, it's known as a what? Yeah, an asymptote. You got an asymptote right there. Your graph rides the x-axis. They do want you to write equations to the asymptotes. So this equation would be what?
X rid of y equals 0.
Y equals 0. Yep. If you ever get confused on is it y equals 0 or is it x equals 0, look at the asymptote. It went and it crossed the y-axis where?
Yeah.
Right at 0. So that's why we call y equals 0. Every point on this line has a y coordinate of 0.
If I said y is
Did you say what?
greater than 0, like would that be point stock or no? Because technically it's true.
No, y is greater than 0 is wrong. It's this line. There's an equation for that asymptote. It's always horizontal lines are always y equals. Okay. All right, keep going. Now here's the deal. If you come from this direction, guys, see my pen? It starts to go up, up. Now what's it gonna do? Is it gonna go like that? Is it gonna, come up, down? What's it gonna do? Up. Okay. Do you guys remember when I plugged in 0? What did I get when I plugged in 0? Nothing. I don't get an answer. So as I get closer and closer to 0, what happens? So let's get a number in between here and here. What's a good number between there and there? 1/2. Okay, so what if I go like this? Sorry, I gotta get rid of this because I need more room. So what if I put in 1/2 for x?
2.
1 divided by 1/2?
2.
2. So over 1/2 up what? 2. What if I put in 1/3, guys? What's 1 divided by 1/3?
3.
Yeah, think of a pizza. One pizza, cut it into 3 parts. You have 3 pieces. It's 3. 1/3, 3. What's it doing?
Writing the y-axis.
It's riding up the y-axis. Oh, so you know what's happening? We have another asymptote. We have a horizontal and we have a vertical. You guys, this is what's so cool about these. They have 2 asymptotes. One's vertical, one's horizontal. The equation to the vertical asymptote is x equals 0. There it is. So every time you graph today, you will have this. Horizontal asymptote, vertical asymptote. The horizontal will be the x-axis, the vertical will be the y-axis. As long as you're talking about the parent. Okay? All right. Now, here's the deal. You know what you haven't plugged in?
Negative numbers.
Any of the negatives. But watch this. This is kind of cool.
Isn't negative the same?
Watch. No, almost watch. If I made 1 negative, what would it be?
1 over negative
1 over negative 1 is negative 1. If I made 2 negative, what would it be?
-2.
Negative half. 3 goes negative, what's the answer? 1 over negative 3? Negative 1/3. So when you change the x value to negative, the y value just changes with it. So you know how, watch this. You know how I graphed 1, 1? Guess what this side's going to be?
negative 1.
-1, -1. You know how I graphed 2, 1/2? I would graph -2, -1/2. 3, 1/3, I'd graph -3, -1/3. So you can kind of see it's over here, right? Now watch, I'll do this other one. Move over 1/2, up 2. Left 1/2, down 2. I think I did over 1/3, up 3. This would be left 1/3, down 3. So it kind of does this. So when you look at the graph, there's a branch on the right and there's a branch on the left. The branch on the right is in quadrant what? 1. The branch on the left is in quadrant 3. They're kitty corner. And there'll always be kitty corner. So what would make this branch go here and this branch go here?
Transformations.
Yeah, but what kind of transformation? A reflection. If you ever see a reflection, oh, this branch goes down here. This branch goes up here. And then they're kitty corner again. Okay? Got it? I mean, I know you don't quite get that, but that's what's going to happen eventually. Okay, so what do you think is super important here? Not all these points. These are the points I think you should write down right now and memorize them. Eventually, you don't have to write them down, just memorize them. These 3 for the positive side, these 3 for the negative side, and that's really all you got to know. And I already did all this with you. When I put in 1, I get 1. When I put in 2, I get 1/2. When I put in 1/2, I get 2. That's all I need to know. I don't need to know any more than that. I know they ride the asymptotes to the right and straight up. Then, of course, then I switched all the signs for the negatives. Then these points. You need to know that. Okay?
Are you department head?
Adrian, I don't know where you come up with these questions.
My mind is wandering.
Okay.
Quite a bit.
Stay with me. Stay with me on this reciprocal.
Are you yes or no?
No.
Okay. What did they look like?
Huh?
Move them?
Yeah.
Yeah, I'm coming. It's coming. Okay. Does everybody have this somewhere on your paper? Yeah? Okay, good. Now, I did graph it for you, so if you want to graph it up in the corner or something, go ahead and do it. Okay? All right. Are you ready to move on? All we did was the parent. Okay. On the bottom, there's something down here that's really important to you. It's right here. would you please circle this, come down here, and rewrite it. And all I'm going to do is I'm going to tell you these are your transformations. Okay? Now, this number on top, A, is the same A is always done all year. What has A done? It's always been your stretch or your compression, yeah. So this is your stretch, or it could be your compression, right? Okay, stretch or compress. What makes it stretch? A has to be what? Bigger than 1. What makes it compress? Smaller than 1. Wow, hang on. Smaller than 1, but bigger than 0. So between 0 and 1, that's a compress. Okay, see this x minus h on the bottom? That's like wrapping it in parentheses. So what's that going to do? It's going to go, that controls your what? Right or left. Okay, what's the plus k in the back going to do? That's up or down. And this is what you'll be asked to graph here in just a second. Okay? There's only 3 things that happen. Right or left, up or down, compress or stretch. And I'm sorry, you know what I should have said? What makes it reflect? What's negative? A. If A is negative, it's a reflection. Okay, you ready? Here we go. This is all I really want you to concentrate on. This one. Oh, does yours say 10 over x?
No.
Yours says 8 over x?
Yeah.
Oh, good, good. Okay, here we go. All right, it's y equals 8 over x. And now let's just talk. Okay, don't start. Tell me what this means to you. This 8. Stretch of 8. Here's why it's a stretch of 8. It's the parent times 8. Isn't 8 times 1 over x just 8 over x? Yeah? Yeah. So this is the multiplier. It goes on top, and that's why it's a stretch. They don't write it like that. They always write it like this. Okay? Okay, so we know it's a stretch. So let's just go over here. Stretch by 8. Do you know what that means, to stretch something by 8? Multiply what by 8?
The y value.
The y values. It's just the y values. Perfect. Now, watch this, guys. Here's the asymptote, the x-axis. Here's the vertical asymptote, the y-axis. Does a stretch change asymptotes? No. The graph gets taller, it goes up faster or down faster, but this doesn't move. What moves a vertical asymptote? What's the only thing that can move a vertical asymptote? Okay, right 2. Boom. The y-axis slid right. Correct? Left. Look at the y-axis. It's moving. Okay, what's the only thing that's going to affect the horizontal asymptote? Up or down. So when you told me to stretch, guess what? The vertical and the horizontal asymptote, they don't move. So you should do this right away. Oh, here's my vertical asymptote. Here's my horizontal asymptote. Do that right now. And then what you should do is this. You should write down the equation for your vertical asymptote. It's x equals 0. The horizontal asymptote is what? Y equals 0. Okay. There you go. Now, did I get that across to you? Stretches and compressions do not change your vertical or your horizontal asymptote. So what does this change? Only the y values. Now, if you know your parent, which you should, your parent was 1 goes in, 1 comes out. 2 goes in, what comes out? Half. And negative, 1/2 goes in, 2 comes out. Okay? This is your parent. I had you copy them. We did it on the previous slide. Now, a stretch of 8 is only going to change what? The y's. Guess what this becomes? 16. Go over 1/2 up 16. Ouch. That's not going to be fun. This one becomes what?
8.
8. This one becomes,
4.
yeah, half. If you take 8 times a half, you get 4. Half of 8 is 4. You know what, guys? This one is probably not a good point, but it is a point. So if I go over a half up 16, over a half up 16, and about here. So that's 1/2, comma 16. Okay, where's this point? 1/8 over 1 up 8. So it rides the y-axis up. Where's this point? 2, 4, right 2, up 4. Okay. Do you know what it's gonna do?
It's
Right.
It's gonna come down until it hits what?
Yeah.
The x-axis. Now you know what? I'd like you to get one more good point for me. Can you think of another good number to divide 8 by? 4. And you get what? 2. So 4 2's on there. 1, 2, 3, 4, up 2. Okay, so here it goes. And now I'm just gonna take off because I know it does that. Okay? You good with what I did? Stretching by 8 gets messy because you get 8 times higher or 8 times lower. Now, did you remember what I said about the other branch? On the other side, you just change your x values, right? To what? Make them all negative, 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 negative. Guess what the y value does? They all become negative, 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 negative. And now you just graph the same points except in quadrant 3. I'm not going to graph this point. This point's just too out there. How about -1, -8? That'd be about right here. 1 left, down 8. -2, -4, 2 left, down 4. -4, -2, 1, 2, 3, 4, down 2. I see it, it's right here. And then I know it just rides. It rides the x-axis, right? There it is. Stretching by 8 did what? Can you kind of look at the graph and say, what? Remember the parent? Now look at this one. This is 8, stretch of 8. What happened?
Spread out.
Hey, what?
Spread out the points.
You know what? From the origin, do you guys realize you're just further away from the origin? You're 8 times further away from the origin. That's what it does. So what would a compression do? Oh yeah, you guys are going to be here. A compression is going to be like this. You're going to be so close to the origin all the way. It's going to look like almost a right angle. That's how weird it's going to look. Okay? Good? Any questions? Nobody. Okay. I don't think I have more to do on this slide. Not going to do, not going to do, not going to do. Okay. Next. Okay, you see this one on the 3rd page? We're going to do this one, and we're not going to talk about any of this. This is not us talking. I'll talk it through right now, okay? Here we go. Can somebody read it to me, though? What was it? Y equals... It's up there, guys.
-4 + 6.
Did you say +4?
-4.
-4, okay. That's what I'm graphing, okay? So all that reading you were doing up there, I don't care, okay? This is probably where I care, right here. That's it. All right. Now, here's the deal. I want you to look at it. I want you to look at the number on top. It's 1. Is 1 a stretch? Is 1 a compression?
Pairing.
It's what?
Pairing.
Nothing. Yeah, it was neither, guys. It was the parent. 1 is the parent. There's no stretch. There's no compression. Okay. What does this mean right here?
Right 4.
That's right 4. On the bottom, it's right or left. This is right 4. Okay. On the back side, it's up or down. What do you think? Up 6. Yeah, this is up 6. Okay. Here's what I'm going to do to you now. Oh, this is kind of different. Usually, I do left, right, then I do the stretch, then I do the up 6. Okay, but I'm just going to tell you this. Take your asymptotes right on, which is the x-axis and the y-axis, and just move them. Right 4, up 6. So where does the y-axis go? Wasn't it right 4? Yeah, go right 4. 1, 2, 3, 4. Here's 4. And just go, this is my new vertical asymptote. Goes right down 4. That's a 4. Yeah, that's still bad. Okay, this is a 4. Okay, so what about the y-axis? It goes what? Up 6. Okay, 1, 2, 3, 4, 5, 6. Here it goes. Okay? Is everybody okay? What I did is I took the old asymptotes and I just slid it right for up 6, and now I have a brand new look for my asymptotes. You remember this used to be the origin? Guess where the new origin is?
4, 6.
Right there, 4, 6. That's it. Now, guess what? You took care of this. You did this. You did this. What's left? 1 over x, the parent. It's just the parent. If you memorize the parent, you got it. Okay, here we go. From the new origin, let's go where? Over 1, up 1. Thank you for remember that. From the new origin, go over 2, up
1
a half. And then from the new origin, go over a half, up
2.
2. Got it. That's good enough, guys. We don't have to sit and do 100 points. There you go. Now, when you did over 1, up 1, well, no, the other side is where? Yeah, which way is over? Left 1, down 1. Left 2, down a half. Left a half, down 2. And there it goes, and there it goes. Okay? So if you can memorize this little action right here, it's pretty simple. Okay? The only thing that I think gets hard for you guys is a stretch or a compression. I think they get hard because you got to think about it. Over 1, up 1. No, over 1, up 3 times higher. You know what I'm saying? Stretches get kind of difficult. I forgot the label. My fault. Sorry. What's the vertical asymptote called? Vertical asymptote is
X equals 4.
x equals 4. Horizontal asymptote is y equals 6. Good. There it is. And there it is. Okay. The domain and the range. Look what it says. Domain. The domain is what? The set of all real numbers except 1. There's only one x value. What?
Except x equals.
So you're saying 0 doesn't get an answer? Let me look. Oh yeah, it does. 0 gets an answer. What's the only x value that didn't get an answer? 4. The asymptote. Look, it says right here, x equals 4. You can't penetrate that line. Guys, put it in. Watch this. You know how it says x minus 4? Go ahead and put a 4 in. 1 over 0 doesn't work, so it's 4. Except what? 4 doesn't work. The asymptote tells you the answer. The range will be every y comes out except one y value. 6. 6 doesn't come out, right? Good? Okay, is there more down here? Nope. Okay, turn the page. All right, this is more just you practicing. Would you just do one on your own now? Go. I hope this is making some sense because you got about 8 of them to do in just a little bit. First, move the asymptotes, right, left, up, and down. Get a new starting place. No, these, I knew you were going to think that. I knew you thought this was the John Lewis method. But John, this is how you do asymptotes all the time. You just get yourself a new origin. John thinks he has postulates and theorems and all written after him.
So would you be an Egyptian if you were given the choice?
What?
Would you like to be an Egyptian mathematician if given the choice?
No.
Egyptian?
What if you got double the salary?
Double the salary? No, I
You
wouldn't
got
want
5,000
to live at that time.
You solved.
Okay,
In 2,000 years.
what's this mean right here? X plus 1 in the bottom. Left 1. Okay, what's this mean? Down 2. Okay, once you know your vertical shift, your horizontal shift, just move the asymptotes around, up, down, whatever. Here we go. Left 1. The vertical asymptote is right here. And that would be what equation?
X equals negative 1.
Yep. Okay, vertical asymptote. Okay, the shift of down 2 takes the x-axis, down 2, so it's just going to be, right? The equation of the horizontal asymptote is? Y equals negative 2, yep, okay. So you've already done this. Name the asymptotes, you did it. We are never going to do this x and y intercepts, not this year. We'll do it next year in pre-calc if you're there. Identify the domain and the range. Oh, sorry, I haven't graphed it yet. My fault. Okay, once I do this and this, what's left? The parent. You hardly have to think if you know the pattern. From the new origin, go where? Right 1, up 1, right 2,
Up 1,
up a half, right a half,
up 2.
up 2. There it is. Done. I didn't make tables because I don't have to. I memorized the parent. Okay? Then on the back side or the left side of the origin, you go left 1,
Down 1,
down 1, left 2,
down a half,
and left a half,
down 2.
and you go that way, and you go that way. Okay? All right. Now think about domain and range. What x values actually got answers? Did 10 get an answer?
Yeah.
Right there. Did 9? Right there. What's the only x value that's not going to get an answer? Negative 1. So you'd say they all get answers. But x can't be what?
1.
Negative 1. Negative 1 doesn't get an answer. Okay? X cannot equal negative 1 because otherwise you get undefined. Okay? What's the only y value that did not come out of this function? Yeah, so everything comes out except what? Negative 2. X cannot equal negative 2. I said that wrong. Y cannot be negative 2. That's it. Did you get it right, John?
Yeah, but wouldn't getting the x and y intercepts be kind of easy? I mean,
They're not hard to get, John. I just like, to me, the answer for the y-intercept is a really small fraction. It's a really small fraction. I just don't want to get into it. It's just more work, and I think you guys have enough on your plate. Okay, it's not hard. I didn't mean it was hard. Just don't want to do it. Okay. All right, guys. I think I'm done. I'm not doing it anymore. So once you get this, would you do number 1 and number 4? 1 and 4.
I have 1. We have them. Yeah.
1 4, guys. Do it now. See what you think.
No.
And did I miss you guys? Yes, I did. All right. 1 4. Okay.
1 and 4.
1 and 4. Just because I never really talked about 1 and 4. I want to see what you think. Okay, there's your answer right there. But you got to fill in three letters: A, H, and K. So, Harry, do you have it? You have number one?
Yeah,
What is it?
I think so.
Okay.
Got that set? No, I'm done now. Equals 1 over, in parentheses, x plus 2 minus 9.
Do you guys agree with them? It says translate the parent 2 to the left. Did he do that right? Is x plus 2 to the left?
Yes?
Yeah.
Yeah? Okay, Harry, don't agree with yourself. I'm making them agree with you. And is down 9 a minus 9 in the back? Yeah. And it said do this to the parent, so you put a 1 up there. Good. But it also says then identify the vertical asymptote, VA for vertical asymptote, and the horizontal asymptote. Can you do this, Harry? I know you don't have
The
that.
vertical asymptote, I believe, would be what?
I don't know. What do you think?
Negative 2?
Okay. But what's this side?
Oh, x.
X equals negative 2. You guys agree? Because the y-axis shifted 2 left. There I am. X equals negative 2. He got it. Okay. What about the horizontal asymptote?
Y equals negative 9.
Yes. Because you dropped the x-axis 9 down. Okay? You guys, okay, you're good. Any questions? Number 4. Okay, 4. Adrian, what'd you write?
Y equals negative 2, 1 over x plus 1.
Okay, I got lots.
Oh.
Okay, I'm trying to see what you said. Negative 2. Then what'd you say?
I wrote it like, so I wrote negative 2, and then next to that there's a fraction that's
You
1.
wrote it like you showed us.
Oh,
you could
then you
write
did
it.
this, something like this.
Yes,
Okay, keep going.
plus 1,
Plus 1.
and outside of that, I had plus 8.
Now, here's the deal, Adrian and everybody else. I did tell you this, but this number is negative 2 over 1. So if you did multiply it, that would turn that into just negative 2. So, okay.
It means
So anyways, we can get rid of this then. Okay, so now the question becomes, did he do it right? It
yes.
said, 1 to the left. Is x plus 1, 1 to the left?
Yeah.
Yes.
Okay, and what else? 8 up, plus 8, looks good. Stretch it by 2. He's got his 2 on top. And reflect it, just means the stretch value will be negative. He got it, that's it. Whoa, sorry, wrong one. This is good. It's negative 2. Okay, now horizontal asymptote, vertical asymptote. What's the vertical?
X equals negative 1.
X equals negative 1, says Molly. Left 1, you're right. And then the horizontal.
Y equals 8.
Y equals 8. Good. If you disagree, you gotta raise your hand. Number 6, go. Number 6. All they're giving you in 6 is the asymptotes. There's a white worksheet that goes with this. Okay, we're gonna move the asymptote to this spot. Y equals 0. To this spot, x equals negative 7. Okay, so really that's all they're telling you. They're showing you where the asymptotes are, and they're saying, hey, write me any reciprocal function that would fit this. Travis, you got it?
This number 6,
Yes, it is.
y equals 1 over x plus 7.
Okay. That's it? Okay. So he says just 1 over x plus 7. Does the x plus 7 do what to the reciprocal function? Yeah, move the vertical, left 7, here it is. Did the horizontal asymptote move?
No.
No. So he doesn't put anything behind it. He could have done this. He could have said plus 0, but why would you say that, right? He picked the number 1. Is that the only function that works with this? False. No. What else could I have put? Could I have stretched it by 2?
Yeah.
Yeah. Here's your parent. Okay. What's a stretch of 2 gonna do? It's just gonna move it further out. What's a stretch of 3 gonna do? Just move it further out. That's all it does. It doesn't change the asymptotes. So this number up here, I didn't care what you put up. You could have put a 12. You could have put 112.
Change it to 2,573.
If you want to graph that, have fun.
Could you put all real numbers?
Yeah, but I mean, they just said, all they're saying is, give me any old function that would work for this. This has to be this, a 0 back here. This number, I could care less what you wrote. Most people write what?
1.
1. Most people just say, just 1's good enough.
Would it be better to put a instead of a number?
No, because they didn't say give me it. They didn't say give me the general formula. They just said give me any function. Okay? All right, guys. The next one I want you to do is one of the toughest ones. 14. It's got everything. It's got everything. If you get 14 right, you get this stuff because this is kind of a tough one. The reason this one's hard is because of the stretch. Oops, shouldn't have said that. My fault. Maybe.
Why would you say stuff like that on a test?
I might have tricked you. You never know. So what does the x plus 5 mean? Left 5, okay? What does the plus 4 mean? Up 4, gotcha. Okay, what does the 3 mean? That's a stretch. Stretch by 3. What does the negative mean? Yes, this is your reflection. Reflect over what though? What are we reflecting over? The x-axis. We always reflect over the x-axis in Algebra 2. Okay? Got it? But I would, if I were you, I would start with your right, left, up, downs. So your asymptotes will move left 5, up 4. I hope you did that. Here's what it looks like. At negative 5, you have a new asymptote right there. At up 4, you have a new asymptote right here. Right here. Good? This becomes your new origin, by the way. Right here.
So wait, if we did 14, you said we didn't have to do the rest of the worksheet.
Did not. Okay, now, you took care of this. Look, look, look. You took care of this. You took care of this. Guess what's left? It's your parent. Just stretched by 3, but reflected over the x-axis. So if you can memorize this again, remember how this goes? Remember this? Now, a reflection means what? These numbers get, I'm sorry, I said that wrong. Stretched by 3 means these numbers get 3 times bigger, so this becomes
6.
6. But the reflection part's gonna make it negative 6. This becomes 3, but negative. This becomes what?
-1 or 1 and
Yeah, there you go. Now, negative 6, I don't know what these are. Let's see here. Right 1, down 3. Here I go. Right 1, down 3. Oh, shoot! It goes like this. Watch, watch. This, and this. That's the way it looked. Sorry. I wish I would have had more time. I would have had 3 more points. Oh, your calendar if you want it. But it's this worksheet every day, so it's no, take it because then it shows you the semester test and all that. Okay, so you got a little bit extra on it. You need one?
Professor, when we do this, we also have to graph the second half of the negative
Yes,
side too.
yes, because, okay, so this is what the parent would have looked like. Reflect. This is the reflection line. You get what I'm saying?
Well, I was just wondering
Yeah.
if we have to go into the negatives as well.
Yes, because you're trying to graph this whole thing. What if you put in a negative 6? Well, then your answer would be negative 3 over
Yeah,
negative 1, which is positive 3.
yeah.
You get negative 6 positive 3. Oh, I did something wrong. Can I?
I was just wondering if we had to do qualifiers.
Yeah, but here's the deal. You know how this one is right 1 down 3? This
Yeah.
would be left 1 up.
Yeah, it's reverse, but
Alright.
That's yucky.
Oh, you're gonna love today.
Oh, yeah. Is that sarcasm?
No. What are you talking about? That is so sincere. The first time I did reciprocal functions, I went home and I told everybody, my whole family, about it.
You didn't even try.
You
failed. Every other teacher was able to at least do one, but you. I'm sorry. You don't get
Every other
that.
teacher has spent all this time and this amount of time.
I had one teacher decide to eat
Half an hour. And they get paid for doing it.
Yeah. That's how bad teacher should have been. Should have been.
No one made me that. It's been a whole year this year.
Is that
He said, we said, oh,
I'm sorry.
He told you. I thought I heard.
Yeah, and then I told him to talk to me beforehand, and he never did. And he never gave me an end or anything.